Good afternoon. While the last people present are being scanned, I would like to welcome you to this presentation from Duttweiler. For those who are not familiar with the company that I'm working for, Duttweiler is a supplier of elastomeric components as primary packaging materials, amongst others for parenterals and mostly for parenterals. And also in case where there is a need for aluminum or aluminum plastic secondary packaging components. Today's speech is under the title of One Step Closer to Zero Defect. And what I'm going to do in this presentation, I'm going to give you an introduction to a new concept for elastomeric closure manufacturing that we have called FirstLine. So I will go with you through the FirstLine project specifications, the closure manufacturing process, and talk about how we have responded in this new manufacturing facility to increasing market requirements in terms of preventive measures, but also in terms of corrective measures. All right, here is the scope of our project that we have worked out we have started up the plant in 2009, so the plant is in operation for years now. So the scope of the project was to install a new CGMP manufacturing plant for elastomeric closures based on the highest quality standards. And in this plant we have installed new state-of-the-art equipment, including but not limited to pass-through washing machines that feature an automatic loading and unloading. And also we have installed the newest generation camera inspection in a clean room camera inspection, so for piece-by-piece inspection of rubber stoppers. And what we wanted to achieve throughout this plant was we wanted to have a lean approach in our manufacturing, and with a focus on the prevention of particulate contamination and of biocontamination, of gross biocontamination. What does that mean? For instance, if somebody would work with uncovered forearms on in a rubber manufacturing plant, in a closure manufacturing plant, there is a chance that on one part in how many million there is a hair that falls on there, and that's something that is not appreciated, of course, in pharmaceutical industry. So we're talking of this type of gross biocontamination. This is the concept, or these are the concept and design specifications. So a lean production flow, that means with little work in progress, so short connection times or short dwell times between the individual processing steps in elastomeric manufacturing, with a focus on the prevention of contamination, viable and non-viable, so gross biocontamination, particulate contamination, and also with a focus on prevention of cross-contamination. What is cross-contamination in our terms? Well, in a manufacturing plant you have different types of products. Let's talk for parenterals about 13 millimeter stopper sizes and 20 millimeter. Well, if we make a batch of 20 millimeters and there is one rogue in there of a 13 millimeter, it's needless to say that the pharma industry doesn't appreciate that, and that's what we call cross-contamination. The plant is designed to work with a minimum number of compounds and colors. Certainly the colors, if you have many colors in your plant, there is a high risk, or you increase the risk of having, for instance, red dots from a red color rubber stopper in a dark gray stopper. So the more you can limit your colors, the more you decrease the risk of this type of contamination. Dedicated technology, camera inspection and pass-through washers, I will come to that later with pictures. A maximum level of automation. There is a lot of handwork involved in closure manufacturing, and unfortunately not everything can be automated, but we have strived in this plant for the highest practical possible degree of automation. All manufacturing as from molding on, is in clean rooms with a strict zoning concept. We have a monitoring system for water and for air that we have systematically implemented in this plant. Our operators are operating in this plant gowned according to very strict rules that come very close to pharma gowning rules. We've worked extensively on a validation master plan and on the execution of this plant while designing, putting in place, and taking in operation this plant. So all that went together with a lot of risk assessments. And in our operations, we had adopted in this plant an ISO 15378 quality system. For those who are not familiar with it, it is, say, it's ISO 9001, but then dedicated for primary packaging component suppliers to the pharma industry. And what the system comprises is clearly ISO 9001, since that is the cornerstone, but it has been expanded with a number of GMP rules and practices. Okay, before I give you a quick visual tour into this FirstLine plant, I'm going to explain in a couple of, or it's just this slide, the elastomeric closure manufacturing process. Going from left to right on the screen, in the very beginning we start with weighing the recipes for the ingredients for our rubber compound according to a very strict recipe. So we take so many kilograms of ingredient A, so many kilograms of B, so many grams of C, etc., according to a recipe that is well defined. These weighed ingredients go into a mixer, and what does the mixer do? It mixes. So it homogenizes these ingredients. What comes out of the mixer is mixed rubber, of course, but it is in a formless shape. So we still need to give that rubber a fixed shape in order to be able to process it later on in our molding department. And this shaping of the mixed rubber is done either by extrusion or by calendering. What comes out in our extrusion operation are these lumps of rubber that you see in the second picture from the left. Are these lumps of rubber. They have a well-defined weight and also shape. And these lumps of rubber, we call them bricks. We are going to mold them in our molding department, and out of the rubber we turn there in the molding, we turn our rubber into rubber products. We turn our rubber that after mixing and extrusion exhibits a plastic character, we turn that into an elastic product in the form of a stopper. All right. These stoppers, and you see that in the third picture from left or from right, as you like, these stoppers are still attached to a waste sheet of rubber from which they need to be separated by an action of die trimming. What is die trimming? Die trimming is an automated cutting of the stoppers out of that rubber sheet. So there you separate stoppers, and what is left is what is visible in the fourth picture. It is a waste sheet. Now the freshly die trimmed stoppers, they are going to be cleaned in a final washing operation. So by washing in a washing machine that is placed in a clean room, we are going to wash the closures. We are also going to add some silicone to prevent clumping of the stoppers or stickiness behavior. And after that, we are going to, of course, we are going to dry them also, and we are going to take these dried stoppers to a camera inspection stage, and from there on to a packaging stage. If there is a camera inspection involved, the packing is also automated. I can use a lot of words to explain this to you, but maybe pictures tell more. Yeah, before we get to the pictures, still have a slide on how we can improve disclosure manufacturing versus what we were used to, or what the market was used to. Well, in that new plant, we have paid extra attention to clean building design from the start on. Also attention, lots of attention for personnel gowning, lots of attention for shielding of our products from the environment while they are in between two stages of manufacturing, for instance, between mixing and molding, or between molding and die trimming. Fast throughput, improved cleaning procedures for both the equipment, but also for the closures in the terms of improved washing programs, a lot of environmental monitoring, a lot of training to the operators. So the operators are trained to operate in this FirstLine plant, in this clean plant, and lots of process validation. In the plant, we have clean room zones that are put in a very logical and straightforward order, with logical product flows and logical personnel flows that are separated. So we have separated material locks, separate personnel airlocks. There is a lot of space between the machines in the existing plant. Over time, a lot of things have been added, and of course, if you have to add some equipment, you take space, and at the end of the day, you end up in quite a cramped place. So here in the FirstLine plant, ample of space between the machines. Materials used for construction of the clean room. We have used the latest state-of-the-art coatings on floors. All rooms are clean room walls. The ceilings are lowered. The lighting has been improved. And also these clean rooms are validated and are kept in a validated state. Here are the different clean room zones that you see. They all have a different color. If you look at the blue color, that is not a clean room zone. That is a zone where either the material is brought into the plant or brought out of the plant. So these are at the left-hand side warehouses for the extruded rubber, and at the right-hand side, these are warehouses for the finished product. Then you see a pink zone. This is a zone of an improved state of cleanliness, where we perform our molding and our die trimming operations. The green zone in between the pink and the yellow zone is a zone for intermediate storage of components after die trimming and before washing. The yellow zone is the cleanest zone that there is, and that is where the washing machine is unloaded and where the camera inspection cabinets are installed. Here are the pictures. So I give you a virtual tour through the plant. We do not go into the plant today, so right into the plant we enter into a visitor's corridor from which we have a sight on the various activities. This is a view of our molding area. What you see is all of the presses in which the molds are. So where we do the molding of the rubber, all the presses have front covers in stainless steel that is easy to clean, that doesn't shed any lacquer, since there is no lacquer on there. What is not visible from this picture, but what is also present, is there is a press. You need to mount a mold into a press in order to shape a product. Well, these molds, they are entered into the presses, assembled, mounted into the presses from the rear end of the press, so not from the side of the molding area itself. Also, the maintenance of the presses takes place from that same maintenance corridor, so that people who work on maintenance of molds do not have to enter the plant itself. This is a view to an extension area. It gives you an impression of the state of cleanliness of the walls, of the floor. The say the transition from the wall to the floor has also been in a way that there are no sharp edges, that there are rounded edges that are easier to clean and where no dirt accumulates. All right, here we have a view. The picture at the left-hand side is an excenter press, and what we see is the feeding opening of the excenter press. The excenter press is the press where you do the die trimming. So what you put in there is the sheet of molded products. Then you activate the trimming die, and the trimming die cuts the stoppers out of the sheet. The sheet will be removed from the side of the excenter press. The stoppers themselves, they fall through the trimming die in a chute that we see at the right-hand picture. And this chute ends in a, well, I tend to call it a coffin that we see on the right-hand side picture that is close to the floor. Of course, it's not a coffin, but it is an apparatus where we do a pre-washing of the stopper in order to remove the silicone that is used as a processing aids for die cutting, and where we also remove eventual debris that can be formed during die trimming. From the coffin we see an elevator that picks up the rinsed stoppers, that picks up these stoppers, brings them to a certain height, and from there on the stoppers fall in a stainless steel container that is not visible on this picture, but that we see here on the left-hand side. So this is a stainless steel container that contains stoppers after die trimming before washing. Again, it is stainless steel. From the form of the shape and the design of the containers, it is quite easy to maintain. And what are we going to do with these containers? Well, we are going to dock them, and you see a docking opening or a docking flange at the bottom of the container. We are going to dock these containers to the washing machine. For that, we use an elevator, and that's on the right-hand side of the picture. So you see an elevator, and you see a very large gripping mechanism that grips the container, elevates it, and brings it to the height of the docking flange at the washing machine. That docking flange of the washing machine is at the right-hand side, somewhere close to the ceiling, but we cannot see it on this picture. What I'm saying here is that, going back to the previous picture, the time that the operator inserts the sheet into the trimming die, that is the last moment that an operator is exposed to the products. After that, things have been automated. Automated transport in these containers, automated docking to the washing machine. This is a view of the clean side of the washing machine. What we see right in front of us is a rotary drum that we use as a washing machine. So it is the principle is the same as a laundry machine at home. Of course, this is not a laundry machine, but the principle is the same. So a rotating drum with perforated walls, provisions for water, for detergent, in this case for silicone. Not likely with a laundry machine, but we have it for siliconization of stoppers. And what you see hanging there, it looks as if it is hanging above the washing machine. While that is a transport funnel that we see back in this picture here, it is a transport funnel where that we use for collecting the stoppers from the washing machine, and from there is a chute into another container that is placed in the clean room, and that is designed to receive the washed and siliconized closures and dried closures. So the thing we still have to do with our closures is we need to pack them. But before we are going to do that, we are going to subject them to a camera inspection. And here you see a couple of pictures from that camera inspection. At the left-hand side, you see close to the ceiling, you see a container. It's a container for finished product. You see below that container, you see a transport mechanism. So the products fall from the container into that transport mechanism, and they are transported into a cabinet, so a laminar flow cabinet in which there is a camera inspection station. This again takes place with an elevating mechanism. Okay. I've talked about personnel gowning and that we have paid a lot of attention to gowning. Well, the gowning is an appropriate combination of low fiber jackets and trousers, coveralls, shoes, boots, gloves, goggles, face masks. And what is also important to say is that there is a restricted access to manufacturing areas. So manufacturing personnel, of course, is allowed. They have dedicated entrances. Visitors are not allowed in the plant, also not from own personnel. The only visitors that are allowed there are people who are carrying out audits. Okay, here are some pictures of people working in the molding area. That's the person in blue, molding and die trimming area. That's the person in blue on the left-hand side. And a person that works in the area between molding / die trimming and the clean room. So you see the type of clothing that they have. You also see that they are wearing gloves that cover the forearms. They have to wear these gloves all of the time. All the time also they have to wear goggles. At the left-hand side of this picture, you see again the same person as on the previous slide, and you see his colleague working in the clean room. So he's fully dressed in clean room gowning, and apart from the goggles, he's also wearing a face mask, of course, gloves at all time covering the forearms. All right, environmental monitoring. I've talked about that before. So there are a lot of data that we collect in this plant. Data like particle counting, so continuous non-viable particle counting. We have an analysis, chemical physical analysis of the water that we use. You have to think of, for instance, conductivity of water for injection, that kind of thing. All these data together with the data collected during washing, they are fed into this monitoring system, and the system is then equipped with the necessary number of alarms or levels of criticality that go up to stopping the operation. Okay. Preventative measures, so shielding the products from operators, from the environment, dedicated containers, automated transport. All right, are we safe with that? Well, we are safer, but we can still do additional things in order to promote the cleanliness of the finished product. What are these things? Well, then we are talking about the washing process and on the removal of particles, on the removal of biocontamination in the terms of bioburden and the toxins. And we are talking of camera inspection. And with camera inspection, the main purpose of the camera inspection is to eliminate the cosmetically defective products from the good products. Cosmetically defective, what is that? Well, it might be a light gray stopper with a black dot. If the black dot is superior to a certain size, we can catch it with a camera inspection system and we can eject it. Washing and packaging, we make use of pass-through washing machines, so with an unclean loading site and a clean unloading site in a clean room. We have automated systems for loading and unloading. When we installed the plant, we have also worked on optimizing the washing process parameters in terms of cycle times, amounts of water used per product to wash and rinse it. We have dedicated washing processes for uncoated closures and for coated stoppers. Coated stopper means a fluoropolymer coated stopper. We've worked on validation of washing processes and continuously work on annual revalidation. And what is also very important to say is that all of the stoppers that pass via the camera inspection, there we have automated the packing of the products. Washing validation, maybe it's a little bit beyond the scope of this presentation, but what we do there is we demonstrate that our washing process have the capability of reducing an endotoxin load with a factor of 1,000, log 3 reduction. We also demonstrate that our products, our finished products, are within certain acceptance criteria for microbiological quality in terms of endotoxins per product, in terms of bioburden per product. There are a couple of other things that we either put against put against acceptance criteria, or or that we document. All right, a couple of words more on the camera inspection. So the camera inspection systems are designed for a clean room environment. In fact, they are placed within laminar flow cabinets in an ISO 5 environment. Camera inspection is designed for various product geometries. Can we inspect all product geometries? In fact, there the answer, unfortunately, is no, because in camera inspection you make use of light. The good thing about light is that it can illuminate. The bad thing about light is that it also throws shadows. And maybe those shadows are in places where you do not want them. So there is a restriction on the geometries that can be camera inspected, but I would say certainly the typical forms of serum stoppers, 13 and 20 millimeter, that's also 32 millimeter, that's no issue at all. Also, particular geometries of lyophilization stoppers can also be camera inspected. Okay, so we do an inspection of the total surface, including the inside of the plug of, for instance, an antibiotic stopper. And what we have also integrated, we are taking profit of the fact that in the camera inspection, the stoppers are brought in line one after the other, individualized. We take profit from that to also do an additional metal check on single product level. Okay, a couple of slides here. So on the bottom part of the slide you see a real picture. On the top half of the slide you see the principle of the camera inspection. So starting at the left-hand side in the upper left corner, we have a bowl feeder that brings the products in a chute and in a line. First, you are going to do a color inspection, a gross color inspection. So is there not a red stopper between the gray? And after that, we are going to inspect every individual stopper from various sides. There is a bottom inspection. This actually is an inspection of the top of the stopper, the flange of the stopper, but it's called bottom inspection since the products are resting on their flange during this stage. And then we do an upper inspection, so from the plug part of the stopper, and then you see almost in the middle of the picture, you see these four things standing there, and those things are four cameras that take a picture every time over a slightly more than 90-degree angle of the sidewall of the stopper. And we have a metal detection stage. There is a provision for automatically taking samples, so the system is programmed, apart from rejecting the defective parts. It is also designed to, from time to time, eject a good part, and that is for sampling purposes, so to put together our sample for finished product inspection. And then, and I think this is also very valuable, there is an automatic packing system. So at the end of the camera inspection stage, the products fall into the bags, and the bags are automatically sealed without an operator intervening there. A view from the outside, so the geometrical arrangement of the container of the in-feed mechanism. At the left-hand side, you see the outside of the camera inspection cabinet. A view on the cabinet with the walls slided open. And this is a view from our plant from the outside. As I said, it is in operation since 2009. We have gone through a first expansion phase last summer, and for ourselves, we think it is of good value, and what is more important, our customers share that opinion in a lot of cases. If there is any interest in seeing this plant, there are some restrictions for visiting it. But if you're a customer of ours who is taking products from this plant, come and visit us. I've gone a little bit over my time. I would like to answer any questions that you have, but already now I would also like to invite you for obtaining more information together with a beer or a coffee at our booth, which is approximately 20 meters here in that direction at the left-hand side. The beer is cold, the coffee is warm, and not the other way around. Very important. So I thank you for your attention.